This module looks at the energy audit used to identify energy conservation opportunities. ECOs can be identified in operational aspects that typically require no or very low capital expenditure. Operational ECOs can be identified through daily operational improvement procedures as well as during the energy review. ECOs can also be identified in technical aspects that require some capital expenditure, typically for technical renovation. Technical ECOs can be identified through walkthrough or preliminary energy audits during the energy review. An energy audit is a site inspection, survey and analysis of energy flows in a building, process or system with the aim of reducing energy inputs into the system without negatively affecting business outputs. A walkthrough energy audit is a preliminary energy conservation analysis following 1 or 2 day site inspections and a survey to identify ECOs. The site inspection is based on visual verifications, studies of installed equipment and operating data, as well as detailed analysis of recorded energy consumption for the defined period of time. Walkthrough energy audits are sometimes called preliminary energy audits. They're the same thing. The Energy Management System Operational Review can be part of an energy audit that identifies operational ECOs. An energy audit that is expected to identify ECOs with technical aspects typically require capital expenditure to be implemented. This is a sample energy audit process to identify ECOs in a heat balance application that generates hot water using gas heated steam. The energy audit consists of 2 main activities. First, site energy audit activities, and secondly, analysis work. Analysis using heat energy is more challenging than electricity energy, since typically there are fewer measurements available on site. If the energy auditor finds that there is insufficient data to carry out an analysis, measurements could be taken using ultrasonic flow meters, portable heat meters or other appropriate devices. An energy audit is always concluded with a report presentation and a submission to the energy manager. The energy report should include technical features and financial evaluation. Technical features include the amount of energy saving, the risk analysis, timescale for implementation, performance monitoring, changes or variations compared to previous normal operation. In the financial evaluation for a typical energy review, the calculation of a single payback period should be sufficient information, though net present value or internal rate of return are also used. The single payback period expresses how fast the investment can be covered by the potential savings. It allows the energy management system owner to quickly examine investment intensity before examining the value of ECOs. The advantages of using single payback periods are that it's an easy calculation. It's got simple terminology, time periods. No knowledge of interest rates, depreciation or inflation is required, and it can be used to compare a number of projects side by side. The disadvantages include that it does not account for savings from different aspects of a project. It ignores savings continuing to be accrued after the break-even period has been reached, and it ignores the true value of money related to interest rates, depreciation and inflation. Once an ECO is approved, it would typically be treated as an energy-saving project requiring a feasibility study or a more detailed energy audit with a more detailed financial analysis that will offset the disadvantages of single payback period calculations identified here. And this is a typical summary table of ECOs resulting from walkthrough energy audits. Operational reviews and energy monitoring investigations, all of which were conducted as part of an energy review.